Hello everyone, so it's a pleasure to be here today to present my individual assignment for the Faculty of Computing and Metatechnology and guided by Dr. Satria Abadi. So my name is Muhammad Ismail Azim ROZMI. My MATRIC number is 202311064221. So today presentation will be focused on fundamental topic in computing, which is system structure. So together we'll explore the key component and concept that form the backbone of any computing system. So what is a system structure? A system structure refers to the organized arrangement of components within a system, which is defining how these components interact and relate to each other to form a unified whole, such as receiving input, processing input, according to the instruction given, and producing output from that processing. This structure can range from a simple series or parallel configuration to highly complex hierarchical combination involving multiple subsystems. So actually, there's a few key characteristics of the system structure, which is component arrangement, hierarchy and modality, interdependency, boundary definition, and types of system. Next, we go to core component of system structure. So actually, we have 5 types of core components of system structure, which is the first one is input devices, function to receive data from the user or external sources. Number 2, we have output devices to display or output the processed data. Number 3, we have I/O ports to facilitate the data transfer between the computer and external environment. Number 4, we have memory, which is to store data and instruction temporarily and permanently. And the last one, we have processor or CPU, which is the central unit responsible for control, data processing, and execute instruction. So these are a few examples of input devices. The first one, we have joystick. Second one, we have keyboard. And the third one, we have mouse. And this is a few examples of output devices that we commonly use today, which is printer, computer monitor, and projector. And this is a few examples of I/O ports that we can find today. The first one is VGA, mini DVI, HDMI, 3 audio, optical audio, DVI-I, DVI-D, thunderbolt, DisplayPort, mini DisplayPort, PS2, SATA, eSATA, Ethernet, modem, USB Type A, USB Type B, USB Type C, USB Micro, and the last one is USB Mini. Then we go to memory. So actually in memory, we have 2 types of memory. The first one is random access memory, RAM. The second one is read-only memory, ROM. So first I'm going to talk about RAM first. So RAM is a primary internal memory used by the CPU to store data and program currently in use. It is volatile, meaning it loses its content when power is turned off. RAM allows the CPU to access data randomly and quickly, which is essential for multitasking and running application. So the second one is read-only memory, ROM. So ROM is non-volatile memory that permanently store data and instruction such as firmware or BIOS needed to boot the computer. ROM is unlike RAM. Data in ROM cannot be easily modified or erased under a normal operation. So example of ROM is like hard disk or SSD. And the last core component of system structure is processor, or we call CPU. So this CPU is often called the brain of the computer. CPU is a complex electronic circuit responsible for the executing, extraction, and processing data. It interprets program instruction, perform arithmetic and logical operation, and also control the flow of the data within the computer system. So in CPU, we have 3 main components. The first one is control unit, CU. 2 to control the operation carried out by the computer system. The second one is arithmetic logical unit, ALU, to perform calculation and logic. And the last one is register, which is a fast memory for temporary data storage during execution. Then we go to the reading mechanism. The reading mechanism in computer system primarily refers to how the CPU reads or fetches instruction from the memory to execute them. So firstly, to read data from memory location, the CPU sends the desired memory address via the address bus, then sends a memory read signal on the control bus. The memory read signal instructs the memory device to output data at that location to the data bus so that it can be read by the CPU. Next is instruction. Order that must be executed. Processing instruction is carried out in two stages. First, fetching instruction. Second is execute the instruction. So this means the processor must perform the work in the step. So we can see a step here. The first one is retrieve coded instruction binary from the memory. The second one is decoding instruction into an action simple. And the last one is the carry out action. The last one is interrupt. An interrupt is a signal sent to the CPU that temporarily halt the current operation to give immediate attention to a more urgent task or event. This mechanism allows the CPU to respond quickly to important external or internal events without constantly checking for them. That can enabling efficient multitasking and real-time processing. So there's two types of interrupts. The first one is a software interrupt caused by software like system call or program. The second one is a hardware interrupt caused by action on the external devices. So in hardware interrupt, we have two types. The first one is maskable interrupt, which can be ignored. The second one is the non-maskable interrupt, which cannot be ignored. So summary for this topic: a system structures refer to the organized framework or arrangement of different elements or components within a system. These components interact in specific ways to fulfill the system purpose. The structure defines how parts are connected, how information or resources flow, and how the system functions as a whole. The structure can be hierarchical, modular, or network.